Hello, Wayland Middle School. Mr. Farley here, and today I'm going to show you an example of how to solve a mixture problem using systems of equations to help you do so. And this word problem that we're going to look at here, I would like you to take some careful notes on either in your notebooks, or if you have this page, which was given to you by Mr. Robinette or myself, you can just write directly on that sheet and take some notes as we go through this video. So here's the problem. Whoever thought ice cream and chemistry went hand in hand? Miss Dulce did. By the way, a little history of Wayland Middle School. Miss Dulce was a former sixth grade science teacher years before you guys were at the middle school. But anyways, Miss Dulce had this idea. She came up with a new idea for her sixth grade chemistry unit. She brought in 10 different types of chocolate ice creams, all having varying concentrations of chocolate. Miss Dulce challenged her students to combine the different ice creams to create the best chocolate ice cream flavor ever. Your little sister, Kelly, won the contest. She blended an ice cream that was not chocolatey enough, which is a 3% chocolate, with an ice cream that was too chocolatey, which was a 20% chocolate. If the resulting ice cream was a mixture that was 5% chocolate, and after winning, Kelly made 150 gallons of ice cream, that's enough to feed the whole school. How much of each type of chocolate ice cream did she use? Very wordy word problem here. All right, a lot of background information that is basically unnecessary. Basically, what we need to do is you're going to take a certain amount of chocolate ice cream, a 3%, certain amount of that, mix it with the 20%, and our goal is to find 150 gallons of that. So if I started writing here, like I'm going to do right here, and I'm going to say, I have no idea how much or how many gallons of the 3% mixture I am going to have, I'm going to refer to that as X. Again, I have no idea how much of the 20% mixture. So I'm going to say that's Y. But I do know that Kelly decided to make 150 gallons. All right, that's the total amount that Kelly will be making. One other thing to add to this table, all right, the 3% mixture, the 20% mixture, and make sure you know the final result, the most delicious chocolate ice cream is 5% chocolate. That's what was determined. So I'm going to write 5% in this bottom box down here because that's the end result. We're mixing the 3% with the 20% to get a 5%. Now, this table is here to help us. And I oftentimes like to add this middle column, which is a percent as a decimal. All this is doing is helping me organize my information, and you'll see where it comes into play in a minute. But all I'm looking for in this column is I want you to take 3% and write it as a decimal. All right, 0.03. I want you to take 20% and write that as a decimal, 0.20. And the final recipe of 5%, write that as a decimal, 0.05. This column, once again, right here, putting a little arrow in it, is only here to help you organize your material. All right, the chocolate in the ice cream. Now, I want to know, I'm taking 3% of a certain amount of ice cream here. Okay, a certain number of gallons of ice cream. 3% of that amount can be written as 0.03x. 20% of this amount, remember, of means times, so 20% of this amount, 0.20, and that's a y. And now I'm doing 5% of 150. That's going to give me a number. I like to think of this as, what's 10% of 150? Well, that's 15. So 5% must be 7.5. Guys, this table here comes in handy because you are now looking at one equation and your second equation. It's organized in a way that you can write your system. One equation is x plus y is equal to 150. And the second one is right here, 0.03x plus 0.2y is equal to 7.5. Now, guys, you have the skills to solve this system. You can choose substitution, you can choose elimination. Definitely avoid graphing. That would be a waste of time, especially when you see what the answer of this is. One other disclaimer, please use a calculator. All right, so what I'd like you to do is pause the video for just a minute, and then I would like you to try to solve this on your own. All right, so if you pause it right now, that would be great. And when you're done solving it, please make sure you resume the video, and I will carry this out for the rest of the way. And you can pause now. All right, welcome back. Hopefully you had an opportunity to solve this equation or solve this system. I am going to solve it out for you. I think probably one of the better ways to do it, maybe substitution would work or elimination. I think what I might do is do this through elimination. And one thing I'm going to do is just rewrite the first equation. Over here, I'm going to multiply this by 100 to eliminate my decimals. If I do that, I get a 3x plus 20y is equal to 750. Okay. Multiplying the top equation by -3 is something that looks like it might come in handy. I'm going to do that. So I get a -3x, -3 times this is -3y, at -3 times 150 is -450. Look here, x is gone. Subtract, I get a 17y is equal to 300. Dividing by 17, now you understand why I said you could use a calculator. And if you do that and you round it, we find out that y is equal to 17.65. And I know this is gallons. Oops, all right. It's 17.65 gallons. So I will need 17.65 gallons of the 20% chocolate. That's what I'm looking for. In order to find the y, to find the x, I would take this and I would just plug it back into maybe this original one right here. So I get x plus 17.65 is equal to 150. Subtracting 17.65, again, further proof as to why a calculator is helpful. If we do that, I think we get 132.35 gallons. And friends, you just figured out what you need to do in order to get the most delicious chocolate ice cream flavor possible. You need 132.35 gallons of X, and X is being represented by the 3%. So this is the 3% mixture here. And over here, 17.65 gallons of the 20% mixture. And there you have it. We have successfully solved the problem. I hope you did too on your own when you pause the video. So Mr. Robinette and I will be available, obviously, to do other questions, but please feel free to refer back to this example to help you with your mixture problems. You will notice that the majority of mixture problems follow this pattern exactly. And I decided to use elimination to solve this. That was just my preference. I think you can also notice right here, you could have easily used substitution by getting an X or a Y by itself very easily. Whichever method you use, you would come up with the same solution. So I hope you enjoyed the video. Hope you learned something new. And please do not hesitate to reach out to Mr. Robinette and I at any time to go over any of these mixture problems. Take care, everybody.